Hello everyone, myself I'm Narayan Sai, URK23CS5084. Today I'm going to explain about the second experiment of Computer Networks Lab, which is IP addressing and subnetting. In this video, we'll explore topics like IP addresses, subnet masks, IP classes, casting types, and binary to decimal conversion. First of all, IP addresses. IP address is a unique 32-bit number used to identify a device in a particular network, and it allows communication between devices over the internet. For example, 192.168.1.10 is a typical home network IP addresses. Then classes of IP address. There are 5 classes of IP address and the ranges are followed. The ranges from 1 to 126 is class A, and 128 to 191 is class B, and 192 to 223 is class C, and 224 to 239 is class D, and 240 to 255 is class E, which are reserved and experimental. Next is subnet masks. Subnet mask splits an IP address into network and host parts. It helps determine which devices are in the same network. Then to calculate how many hosts are in a subnet network. The number of usable hosts in a network is calculated by using 2 power n, which is the NSA number of host bits. For example, if there are 26 masks, which means there are 6 host bits, that is 2 power 6 minus 2, which is 62 hosts. Next, typecasting. Casting defines how data is sent on a network. There are 3 types of casting, which is unicast, which is 1 to 1, and then broadcast, which is 1 to all, then multicast, 1 to many. And next, public versus private IP. Private IP addresses are used within a local network, whereas public IPs are globally unique and routable on the internet. Next, subnetting based on borrowed bits. Subnetting divides a network into smaller parts by borrowing bits from host section. Next, let's see about the binary to decimal conversion. For example, let's take the example 11000000. This is a binary. Let's convert it into decimal. Here I have taken the binary number, which is 11000000. Binary numbers are made up of only 2 digits, which are ones and zeros. Each position in this binary number has a place value, which is a power of 2. So starting from right side, the place values are 1, 2, 4, 8, 16, 32, 64, and 128, which is the multiples of 2. These represents 2 power 0, 2 power 1, 2 power 2, and so on up to 2 power 7. Now find the decimal value. We multiply each binary bit by its corresponding power of 2. Whenever there are 1, we include that value, and when there is 0, we skip it. So here how it works. So there is 1 into 128, which is a power of 2 power 7, and we have 1 at 2 power 6, so we multiply 1 into 64, which is a power of 2 power 6. So there are zeros, so we don't consider it, we skip it, since 0 into anything is 0. So finally we add 128 plus 64, which is equal to 192. So the binary number 11000000 is equal to decimal number 192. So these are the stuffs we learn in this experiment. Thank you.